Hey, how are you today? Hope you're doing well. Gonna do a little homework review with you, and saw some of you did not do so well on the homework. That's unfortunate, but the percentages that some of you got are just unacceptable, so you're gonna have to redo it. All right. Hopefully this video will help you. You need to maybe ask for some more help, possibly. Once again, I got no responses from anybody here. It's like I'm teaching the wall, which is a little bit hard to do. So please, why don't you ask me for some help? All right. Now, let's go through these problems, and I want to point out this slide yet again that I said would be really, really, really helpful for you if you kind of understood the stuff on this. I added a couple little notes here. There is one other type of problem, and that's just simply finding the degree measurement of the arc. All right, but the problems are either finding the arc length, the sector, or the segment, or finding the degree measure of the arc. Okay, that's the general thought here, and we'll keep on coming back to this as we go through the problems now. All right, so this problem was like, I think the first four problems were kind of like this. You're finding the measure of the arc. Okay, so when you see the M and then dB with the arc sign, that's a minor arc. Okay, so you're finding degrees here. Okay, you're just finding how many degrees this minor arc takes up. And that is the same as the central angle. Okay, so like you're going from D to B. So you're not actually measuring the length here. You're looking for the angle this arc takes up right here from D to B. All right, so a couple things to remember is in a circle, there is how many degrees? 360 in the whole circle. Okay, hopefully somebody taught you that somewhere in your life. All right, now this line that cuts the circle is definitely a line that cuts the circle in half. It's called a diameter. It goes halfway through the circle. So if we go from T, B to O, that is equal to how many degrees? Well, it's half a circle. So that's 180 degrees. All right, so you have 180 degrees in half the circle, and you are looking from D to B, which is this part. Okay, so you just need to subtract TB, and TB is equal to 90 degrees. All right, so the measure of this arc here is just going to be 90 degrees. All right, so when you're dealing with this, you're just finding the arc measure, and you have to like subtract parts. Subtract from 180, subtract from 360, subtract what is given to you. Bunch of different possibilities there. Okay, let's go on to this one. Okay, what is the length of the arc shown in red? So this one is arc length. So if you don't remember how to find arc length, you go back and you look at the sheet and go, it's a fraction of the circumference. Oh, look, here is the arc length formula if I'm given degrees. So, you use this formula, okay? N is representing how many degrees that arc is taking up, and R is representing the radius, which is, in this case, 13. So we just substitute into this formula. Okay, this doesn't look so bad. All right, so just put the number in for N. Okay, you guys can do this, okay? It's not like I'm trying to build the Great Wall of China here, okay? I'm just substituting a couple numbers in a formula and simplifying it, all right? R is equal to 13. So R is equal to 13. There we go. Now what we have to do is simplify this, okay? And that's where maybe some of you guys are running into problems, but you have to be able to simplify fractions. You got to reduce, 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 reduce. And there's a couple different ways you could do this. You can either reduce this fraction part first. You could cancel some of these numbers with the fraction part too. You could multiply straight across and then reduce it at the end. Okay, but you do not want to multiply by pi. It says type an exact answer using pi as needed. So you don't want to put pi in your calculator. All right. So what I like to do first is try to reduce this fraction 30 over 360 as best as I can. Okay, so this 0 and this 0 cancel out. So we have 3 over 36. 3 over 36 Divide both by 3, that's 1 over 12. Okay, here we have 2 times 13, which is 26. Okay, so I'm not going to actually multiply that out yet because I see I can cancel out something else. I could cancel this 12 and this 2, so this will become a 6. All right, and so I'm left with just 13 pi on top, and on the bottom I have 6. Okay, so that's what I'm going to type in as an answer in the blank, and I'm looking for a length here, so my units are just centimeters. All right, so that's how you would figure out arc length. Just use that formula where it's a fraction of the circumference. Okay, next question is asking you for the area of a sector. So for area of a sector, I'm using, go back here, not the arc length formula, but sector, which is part of the whole circle's area. So I'm using this formula. Okay, so boom, there's the formula. Okay, so it's very similar. You're just multiplying by pi r squared, which is the formula for the area of a circle instead. All right, so what we need to do is just substitute the numbers again. All right, it's basically the same as the other one. You just got to reduce, reduce, reduce. Okay, so you have 40 over 360, and then you have pi r squared. Okay, so it's pi times r squared this time. Okay, 15 squared is 225, so we have 225 pi. You want to make sure to square this number here before you do any multiplications, because otherwise you break the order of operations. 40 over 360, that just reduces to 1/9, because these two zeros will cancel out. Okay, then you have 4 over 36, which is 1 over 9. All right, and I don't know if 225 divides by 9. I have a feeling it does. Okay, so that's how you would do that one. Divide 225 by 9, and you get something pi. All right, let's go to this one. Now things are getting a little bit more tricky here. The shaded segment of a circle. But once again, this is not like you're doing something completely impossible here. It's just like putting together some things that we learned about this year. Segment area. Okay, so that's part of the sector, it says here. Okay, so you take the sector area and you minus the triangle. You see the triangle isn't shaded, so you're subtracting out the area of this triangle, and you're ending up with the area of the shaded region right here. Okie dokie, artichoke. So that's the general thing we're trying to do here. All right, so let's go ahead and figure out the sector area real quick. All right, I went ahead and calculated it. It ended up being 6 pi. All right, so, you know, stuff will cancel. Okay, that's basically it. I mean, 60 over 360 is 1/6. 6 squared is 36 pi. And then 36 divided by 6 is 6 pi. All right, so hopefully you followed all that. All right, area of this triangle here. So this triangle, you might not know how to get the area of this triangle. Okay, the area of any triangle is 1/2 the base times the height. Okay, oops, sorry, wrong pen there. Let me pick up a black one. All right, 1/2 the base times the height. So we need to figure out a base and we need to figure out a height of the triangle. So I took this triangle, I drew it down here. So this is 6. We could say the base is equal to 6. All right, so we have 1/2, or, you know, if you're using a calculator, you put 0.5 in, it's a little easier. The height is, we have to determine it, okay? So if this is 60, okay, how do I know that's 60? Well, you see this angle on the outside is 60 degrees, and that's the same as the central angle here, that going like this. Okay, so they're both 60. All right, now if this angle is 60, because this actually is an isosceles triangle, in fact, it's actually an equilateral triangle, and the reason why I know that is because if the central angle is 60, and this radius is 60 here, okay, this other radius is, I said 60, I meant 6, okay, this other radius is 6. All right, that means that these two angles here, they got to be equal. And if these two angles got to be equal, I already used up 60 degrees. Okay, I only have 120 to split equally here and here. So that means that this angle is 60 and this angle is 60. So we have a equilateral triangle. All right, but we need to figure out the height of this triangle. That's the point here. All right, we got to figure out the height of the triangle. Both the radii are going to be the same all the time in these circles here. And the ones that I'm going to give you, you're going to be able to make into a 30, 60, 90 triangle or a 45, 45, 90 triangle. Okay, so if this is 60 degrees, okay, we need to figure out what the height is. Okay, so the hypotenuse is 6, which means, you see this triangle is actually cut in half here. So this is 30. And which means that this part, which is the short side, is 3. Okay, the short side's 3. If the hypotenuse is 6, the short side is half of it. Okay, that's back to the previous lesson. If you don't remember that, then I'm sorry, but it goes like S is the short side. The middle side is square root of 3 times S. The hypotenuse is double S. So if you have the hypotenuse, you divide by 2, you get the short side. And then you multiply by square root of 3 to get the height. So anyways, the height here is going to be 3 times the square root of 3. Okay, and that's like the hardest thing in this whole lesson here. Okay, you got to break down these 30, 60, 90 triangles, which is just what we did in the last lesson. So that's why I put these two lessons right back to back. Okay, because I knew it was so like related to each other. All right, so we would just go ahead and take half of 6 is 3. 3 times 3 is 9. So this becomes 9. Then we have the square root of 3. And you don't want to put the square root of 3 in the calculator until your final answer because it gets really ugly. All right, so now we need to go and calculate the segment area. So this is the final answer step. So now we can pick up our calculators and go ahead and do area of the sector, which is 6 pi. And if you don't have a pi key, just use 3.14. Minus 9 square root of 3. And you put that into the calculator and then make sure to round it how they're telling you to round it. Okay, I don't know how they're telling you to round it. I lost that part of the directions. All right, so anyhow, there you go. You'll get some kind of decimal approximation. And this is in centimeters squared. All right, let's look at another one kind of like this one. Okay, so once again, you're figuring out the segment. So we go back here, and remember, it is sector area minus the triangle area. Okay, so, all right, I already figured out the sector area here. It's 90-degree angle here, so 90 over 360 is reduced to 1/4. The radius is 10, so you do 10 squared is 100. You do 100 divided by 4, you get 25 pi. The area of this triangle is a lot easier because this is just a 90-degree angle here. The base is equal to 10. Okay, and the two radii are always the same. The radius in a circle is always the same as the other radius. So they're both 10 here. So you do 10 times 10 is 100, and you take half of it. So the area of this triangle is just 50 centimeters squared. Now to figure out the segment area, you have to subtract the two things there. So you take 25 pi minus 50, and then you get your answer rounded. All right. Last one to go over here is a little bit different. We're trying to find the radius now given the sector. So let's go back and think about what the sector formula is. We just used it on the last two problems, by the way. Actually, the last three problems. So here it is. Okay, there's the formula for a sector. Now let's put in what we know. Okay, go ahead. Let's go ahead and substitute what we know. What do we know? We know the area is 36 pi. Okay, so we're going to replace the a with 36 pi. We also know that the n is 90. So we have 90 over 360. All that's given to you in the problem. Okay, we have pi here. We want to figure out the radius. Okay, so that's r squared. All right, so what you do first, probably reduce 90 over 360, make it into 1/4. All right, and then I want to get rid of this pi, so I just divide both sides by pi, and voila, the pi will cancel. Next thing, I want to get r squared by itself, so I'm going to take 36 times the reciprocal of 1/4, which is 4. Okay, and the final thing is I take the square root of both sides. So I'm square rooting 144, and I get the radius of 12. Okay, guys, that's it. Have a great day and a nice weekend.